Next sample problem. The leaves of a rhubarb plant contain a high concentration of oxalate ions, C2O4 2, which is in fact very poisonous. To determine the percent of oxalate ions, a student measured the mass of some leaves. The student grounds up the leaves and added excess calcium chloride solution to precipitate calcium oxalate. The student tested 238.6 grams of the leaves. Now, the dried mass of the calcium oxalate from the leaves was 0.556 grams. What was the mass percent of oxalate ions in the leaves? Now we're looking at it and going, oh my goodness, this is a really long question. Right? So where do we start? Where do we always start? Formula, right? Our actual chemical equation. So let's start off with the chemical equation. I'll give it to you guys just so you guys can kind of, know where we're going. So all we're looking at is we're trying to find the oxalate ion. Right? We formed the calcium oxalate in our question. So now we've got our equation, and so all we've got is a dissociation of the ions. So we've got calcium ions, the oxalate ion, right, in aqueous solutions, and it forms a solid calcium oxalate. So now, using that, take the information and go about trying to devise a plan to solve the following problem. Now, one of the questions says we've added it in excess calcium chloride. Right? So what we've got is we've got this double displacement reaction, and the only part we've kept were the parts that helped form the precipitate. So we didn't care about the rest of the equation, right? Because it's only going to make things a little more complicated. So we've only, this is the part that I kind of stated at the beginning, where it says you're better off, if you've got certain precipitate equations, you're better off using the net ionic equation. Now in this question, right, we form the precipitate, which is the calcium oxalate. Right? That's that. So all we care about, even though we're adding excess, right, we know that we're adding all this extra calcium chloride to get this reaction. But all we're trying to do is we're trying to collect the actual precipitate. So we've collected this much of precipitate. So what we want to do is we want to find out the amount of the oxalate that's actually going to be used to end up forming this precipitate. So what do we have in terms of numbers for this question is, we've collected 0.556 grams of that. So we've got our mass, and always in terms of stoichiometric problems, what we want to do is we want to take the mass, right, of this, the calcium oxalate. So what we want to do is we want to find, right, the molar mass of calcium oxalate. And we're going to divide the two together, and the molar mass is 128.1 grams per mole. So grams cancel out, and we're left with 0.00434 moles. So we've got 0.0043 moles of the calcium oxalate. So our unknown is the oxalate ion. So C2O4 2. Our given is the calcium oxalate. And we've calculated the number of moles and molecules. So we've got 0.00434 moles. We're trying to find the number of moles of the oxalate, but the ratio is 1 to 1. Because the ratio is 1 to 1, exactly, x is equal to the same thing. So the x of the oxalate is equal to the same number of moles as we've calculated for the calcium. oxalate, moles. Now, we've got the number of moles for our calcium oxalate. Question asks now, we've got 238.6 grams of leaves that were actually being used, right? But this is the number of moles of the oxalate ion. So in order for us to find out how much of it is in terms of a mass, what do I have to find? The molar mass, right? So I find the molar mass of the oxalate ion. Now, the fact that we've got this -2 does not affect calculating the molar mass. Because the molar mass is, right, just the regular, the mass of 2 carbons, 4 oxygens, as normal, right? So when we have the number of moles to find the actual mass of it, we multiply it by the molar mass, and the molar mass is 88.02 grams per mole. Moles cancel out, and I'm given the mass is 0.382 grams. So we've got 0.382 grams of the oxalate ion. Now, question asks, what is the mass percent? Okay, what is the mass percent of the oxalate ions in the leaves? So, what was the mass that we've collected of the oxalate? 0.382 grams we've collected. What were the mass of the leaves?
238.
Exactly. That's our entire sample, right? 238.6 grams. So we're taking what we've collected of the ion that we need, we divide it by the entire mass of the sample, right? We take those two numbers, we multiply it by 100 to get a percent, and the percent comes out to 0. At least number of significant digits in our question 3, so the answer is 0.160%. So, the mass percent of the oxalate ions in the leaves is 0.160%. So you see now, in terms of stoichiometry, how stoichiometry works, even though we're not looking at, we're actually looking at ions instead. Right? So stoichiometry is going to be a big part because we're actually going to be using stoichiometry. We're going to continue to be looking at it in the coming units. So please don't forget these methods. Right? So they all work the same way. So we've calculated the number of moles. Right? We've been given this amount, this mass, 0.556 grams of our precipitate. So using that, we can actually figure out the number of moles of our ion. And then take that, use the molar mass of the ion to actually find the actual amount of the mass.